Yes, good afternoon. And we're moving into a session more looking a little bit more on technology based. So we will have a content-packed 55 minutes ahead of us and focusing on digitalization as a tool for sustainable production logistics. My name is Magnus Viktorsson, and I'm a professor of production logistics here at KTH. And I'm sitting here with my colleague, Jannike.
Yeah. My name is Jannike Bolseth-Hauge, and I'm an associate professor in production logistics here at KTH.
So this session will be a joint session between us as researchers and with some key industrial partners.
Yes.
And but perhaps first, would you like to present our team at KTH?
Yes, we are 9 researchers. And we are focusing mostly on looking at how digitalization can actually enable sustainability. And since we're in production logistics, we look at different levels in logistics, from the small workplace unit until the entire supply chain and urban mobility aspects. And our most concern in all our activities actually to look at the connections between the physical environment and the digital environment. Thereby, for instance, looking at how we can use cyber-physical systems and connect them with real-time information so that we create an industrial IoT environment. And with all we actually look at, we also look at what sort of application can we have for improving the long-term effect, like using scenario analysis for that, or actually also support operational monitoring, which is more in the short time. But all in all, what we try to achieve is, of course, an improvement of the performance, specifically for the industry then on the long-term run. Yeah, but how you can tell about what we're doing today for us?
That's good. Yes, so we will look at the scheme today. We will have actually divided in 3 sessions. So we thought we could have on different systems levels, looking at first the supply chain level, looking at the industrial system, how can production logistics be, digitalization in production logistics be realized in that level. And then tracking, tracing upstream in the supply chain, for instance. So we will have a short video on that, 5 minutes, and then we will have a discussion on it. Then we move on to what we could say is a site level, factory level, looking at materials handling. And we will have a short video on that, giving examples, and then also a panel discussing that. And then at the end, we will have the third level, the really workstation level, looking at what type of technologies are available in order to have real-time tracing of goods and at the workstation level, supporting the operator. We will have a video on that and a panel. So basically, the idea is to demonstrate by 3 short sessions those 3 levels, together with our partners, as you see on the slide. So, by that, actually, I thought we could just move into the content.
Yes, that sounds good.
And let's move on to the first movie on supply chain level research.
Hello everyone, my name is Taran Kumar Agrawal. I'm a postdoc researcher at KTH.
Hello everyone, my name is Ravi Kalayarasan. I'm an industrial PhD student at KTH and also employed at Scania.
We, today in this presentation, will give you an overview about supply chain visibility that has become the need of the hour. We know that currently the supply chain globally has been severely affected due to the pandemic situation. Manufacturing has been disrupted. There is delay and stretch in the delivery time. The consumer's demand has been moved to essential goods, and raw material supply has been delayed. In order to mitigate such impacts in future, OECD in one of their meetings in 2020 highlighted areas for improvement, which includes automating processes, digitizing the supply chain, expediting certification process, rethinking resilience in the supply chain, and most importantly, increasing transparency and visibility. We at KTH, in order to better understand supply chain visibility, are undertaking a project called LOVIS, Production Logistic Visibility. The project aims to understand visibility and material flow internally and externally. And in order to do so, it takes visibility at two levels. One, internally in the supply chain for understanding the material flow and dynamic transportation, and externally for better prediction. The result of this would be in form of framework that would help in mitigating supply chain risk and enhancing competitiveness for the participant companies. These are some of our partners in the project, and it's worth mentioning that the project was listed among top 100 in the IVA 2021 list. To start with, we actually started by doing a study, Delphi study, with 26 experts from Swedish manufacturing industry to understand supply chain visibility and crucial information that need to be shared and recorded in the supply chain. We categorize these information into three categories: supplier-related information, buyer-related or OEM internal information, and customer-related information. We found that purchase plan, inventory levels, and deliveries were among the crucial information that needs recording and sharing in the supply chain.
By reviewing the literature, we could also develop a framework for visibility. Four main themes and related subcategories emerged. Antecedents include factors which needs to be in place in order to establish visibility. Drivers contain factors which motivate companies and organizations or demand them even to focus on visibility. Barriers and challenges describe the factors which can act as a limiting factor to establish visibility. And lastly, we have effects of visibility or implications of it, which can in turn be divided as either improved capability or performance. Blockchain is one of the upcoming technologies which have shown potential to improve visibility. In one study, we developed a blockchain-based collaborative framework which can enhance trust and ensure privacy amongst actors in the supply chain. In another study, we are supporting the case company to improve the visibility in their inbound flow. By mapping the current state, we could find that they suffer from real-time visibility, lack of real-time visibility in their inbound flow. And part of the solution is to attain visibility on pallet level without being dependent on the trailers, which is not owned by the case company today. And this is expected to fill the gap which is the company suffers from today. And also in this study, we are understanding what type of information to put in a visibility system and understand its relation in relation to the other areas in the framework. And the expected outcome of this is improved analytical capabilities such as risk management and improved predictive abilities, but also improved performance such as customer service and sustainability. And based on this, going forward, our research include understanding visibility in the extended supply chain, further testing and evaluating technologies for visibility, and also understanding and investigating contingencies for supply chain visibility. Thank you.
Thank you for that. Welcome back, I should say. And I also welcome the panel on supply chain visibility. Jannike and me have been joined by Dennis from Mainly AI.
Thank you.
I don't think we should dwell on the details on this project specifically. I think the point of showing this video was to show an academic industrial collaboration project where we address supply chain issues, and it's really complicated, if we say so. There are so many stakeholders in this case. They have so many different objectives. There are a multitude of standards. Adding to that, if we add the sustainability and the need for climate action, that adds to all of this, all of these parameters to include. That's my perception of this, Lovis. From your perspective, then, you're a small company, you're starting up in the AI business, and you have a mission of targeting climate action and kind of connecting the dots. How do you see on this? Have you any reflections on what we saw on supply chain level? What can AI do, basically?
Absolutely. It's a very good question, and we obviously see many opportunities with the AI technologies. They open many doors, so to speak. Amongst others, the new technology allows you to not only visualize and predict a certain outcome, for example, your carbon footprint, but they will also allow you to optimize your different objectives. For example, lowering your carbon footprint versus your production volumes, for example. Another example could be used in the medical industry, where you can look at the preventive maintenance of the machinery or the equipment, for example, so you don't have to waste the batches if the machine breaks, so there is not that much waste, potentially biohazardous waste there as well.
Yeah.
So the opportunities are quite many as we see them.
Yeah. Yeah, the AI business, I feel, is growing everywhere.
It is, and I think the AI and machine learning technologies will play an ever greater role in the production and in the societies as a whole.
Yeah. And you, Jannica, I know we've been working, or you've been working mainly on supply chain projects and also related to urban logistics, looking at production in a societal context, so to say. Do you have any reflections from that?
Yeah, I think we actually saw it quite well in the video, the complexity, and also Dennis just mentioned how complex the old things are. And if you look at production, specifically here in Södertälje, we have two main production sites in the middle of the city. It is Scania main camp for production, and it's also Astra which is producing, and that means that we have a lot of incoming traffic. You have to supply with the materials, and you have to get out the goods again. And the interaction with that, the effect that has, and what is actually having the consequences for the infrastructure we have here. We have one of the biggest ports in Sweden, actually. And we also have the situation that we have the income to Mälaren, so that we just have 3 bridges. And that, I think that shows the complexity which we have to take into account. Do we want to have production here in the city center? And what does that actually cost? How that does influence? And it's really important for the AI to analyze it, to get the data, to improve it, so that the citizens living here have good living conditions, actually.
Yeah.
I think that is very important.
Yeah. I think one aspect that the project tried to address is also the data availability.
Yes.
Specifically in supply chain questions, I think that could be a real challenge in getting...
And that is where we can see, for instance, other systems like the ITS systems, the transport, where you can actually use data from everywhere. You can get it from, let's say, it's something happening in Nyköping. You could actually have that, knowing that, analyzing that, so that you know that the trucks deliver here will be late, or so you can perhaps get someone else. Then we will avoid a lot of congestion. And actually also staying around, using resources on just waiting for getting your slot for driving your goods to the final warehouse.
Yeah.
So I think the data, but also who's owning the data, is really important. Privacy issues will then in the societal context be really relevant.
Yeah. Do you have any experience in data availability? I mean, sometimes you hear, oh, there's so much data everywhere. That's not an issue, but is it an issue, or what do you think?
That is correct. For a company such as ours that nourishes itself on the data availability, and that lays as a ground for all the machine learning and AI models that you can develop.
Yeah.
Obviously, yes, there is a lot of data around, but there is this question of which data do we actually use? What's the, what should go into our model, what should not?
Right.
And is that data clean? Is that in the machine readable format? So all of those questions obviously need to be addressed. And then the privacy aspect of it is huge. I mean, whenever we speak about data nowadays, everybody has GDPR ticking in their heads, right?
Right.
So, but yes, obviously in the last sort of 10 years that there's been a big leap towards the availability of data that companies such as ours can use for analysis.
Interesting. So, linking back to sustainability, then how do you kind of relate to sustainability when you build your models at mainly AI? Would you say?
Well, the models that you build is they can obviously one model can only, let's say, predict about how things will look in the near future based on what has happened in the past. However, to gain the full power of these models, you need to have several of them, and then you need to be able to optimize those against each other, so to speak, because a very simplistic example is where you can have, let's say, we want to minimize our carbon footprint. Well, great. Well, then let's turn off all the factories in the world, right? Then we all die. Zero carbon footprint. But then on the other hand, if we want for everybody to be healthy and produce tons of medicine, for example,
right.
We'll turn all the factories to to 120%, and then the pollution is going to be through the roof.
Yeah.
So there is that balance. Where do you find that balance where you maybe lowering your production levels just a little bit will have a much bigger impact on the if we continue using the carbon footprint example, that what you get out of that is overweighs basically what you lose on by diminishing your production, for example.
Interesting.
I actually think that the AI will help us to do it smarter, so that we, with all these data availability, when we have that, it will help us to reduce the waste we use on the transportation or the practical issues in a smarter planning and a smarter operation, so that again will have a positive impact. So we perhaps do not need to reduce the production as such, but all the other processes. We heard it actually earlier in the previous panel much about the lean aspects. I think that will have a big impact for us on the sustainability. Specifically in the production logistics, where it's so much where we don't see it, we don't measure it, and then we don't even have data, and then we do nothing. We cannot do anything with it, and that there we see a big change during the last years, I think.
Sometimes you get the feeling that there's so much technology and solutions out there. Why isn't it more used? We saw in the video there were blockchain discussions. You heard sensors. GPS. I mean, the data technology solutions could potentially be there, but do you have any thoughts on what is the main obstacles for companies actually taking steps or
I think there are several aspects to that. This data availability really is a fairly recent phenomena, as in data availability of data that can actually be used by the machines to gain any insights out of that. So that's one, and obviously then the second aspect of this is that the companies, they might all have AI, machine learning, very high on their agenda,
right?
But the know-how is just not there, right? It takes time to build up these departments. It takes time to build up or capture the data flows in a very structured way that can be used for machine learning. So all of those things come into play. Now, luckily, there are frameworks and there are things out there, the new technology produced by the companies such as ours, that will allow to facilitate and to improve the speed or the pace of the adoption of AI technology. So I think in the next few years we'll see really a boom in the use of these technologies, and they will be more widely accepted.
Yeah.
I would actually like to add that when we've been much out in the industry, looked at how to implement all these new technologies, and it is simpler in the theory than it's actually in practical. We go to warehouses, we have nothing there. It's you cannot actually get the data because it's something shielding, or you have aspects of scattering data and all these aspects, which is very hard to predict in the theory, or even in our lab, which we have down here. Is very challenging, and I think that is one of the hindrances. You also said the knowledge. It is not about just the knowledge of the big companies. We also have a lot of SMEs, which also need to take part of this to actually bring the things. And that is why I think it's also so important for us to have a very tight industry relation to in production logistics to see how it works. So.
And I think in our work we have a wide spectrum of collaborations as well. I mean, from very brief projects in courses, like the course you're running right now, up to industrial PhD students that are long-term commitments from companies. So I think it's important to have that type of interactions. Because I also reflect when you said that's one big hindrance is the investments that are done already. You sit with the equipment and stuff and factories that are paid off since long, and so it's a brownfield that is. It's a bit tricky to tweak. Just our elevator story here.
Yes, it's that's hard to see, and it's also a very rapidly changing technology. Which if you're a little bit late, then you've actually missed out. So
just want to explain the elevator story is we have an AGV here in our lab, and we tried to get the AGV to talk to the elevator to open the doors, and it was a huge investment to get the two to talk to each other.
Because we didn't ask for it when they built the...
Exactly.
And that was the standardization issue, actually. Because if we do anything changing that, which is costly, but it's also a standardization issue. So...
So all of those small things. Yes.
But I can just add to that this is actually why I strongly believe that we will see more and more of this technology coming into our daily lives and being accounted for in production and logistics, is that exactly that fact that we are more and more aware of the fact that this is, the data needs to be captured and it can be used. Data is an asset, and all of these sensors and the equipment to read off that data, they're being built into the machines nowadays. So that will make things much easier for us going forward, for AI companies to capture that data and do something about it.
And there, I think you, as you're the head of department, you can have an important role to build the bridge between both industries and also for the academia situation. Perhaps you could say a little bit about that, how that is possible.
Yeah, and I think that's the story of this campus, to be honest, if we go a bit internal here. The story of having KTH in Södertälje is to have a very tight collaboration with the main industrial stakeholders. So otherwise it would be more rational to have it at one place, but this is really getting a edge computing, so to say.
The field.
Thank you. I think it's time actually to move on to the second part of this session. So we will now look on a short video on digitalization more on factory level, on materials handling level. So I hope we can see that video coming on.
Hello everybody, my name is Eric Flores Garcia.
And my name is Yongkok Jeong.
We welcome you to the presentation of our study, which we've titled Digital Twin-Based Services for Smart Production Logistics. Production logistics refers to the movement of materials and information within the physical limits of a factory, and involve activities such as material handling, warehousing, packaging, picking, information management, or transportation. Consider the case of two of the newest trends in the automotive industry: increased customization and electromobility. Already, without these two trends, production logistics represents nearly 55% of the space and 87% of the time in manufacturing. However, increased customization and the manufacturing of new and existing platforms means handling more parts, reducing delivery times, and increasing traffic, but with the same space of a factory. Clearly, traditional analytical tools, experience, and ingenuity are insufficient for meeting new and future challenges in production logistics.
Smart production logistics include complex systems containing not only physical and virtual devices but diverse stakeholders with unique requirements and needs. Therefore, manufacturing companies must develop digital twin-based services providing holistic comprehension.
Developing a framework applying Industrial Internet of Things and digital twin-based services in smart production logistics is crucial, particularly if we are to achieve the high operational dynamics, intensive human involvement, and manage uncertain events on the factory floor that are so frequent during the execution of smart production logistics. The purpose of this study is to analyze the combined use of digital twin-based services and the Industrial Internet of Things in smart production logistics. The framework applies 5 dimensions of digital twins, including a physical environment, data connection, virtual environment, data storage, and digital twin-based services. The physical environment includes resources executing and IoT devices sending and receiving data about material handling tasks. Data connection facilitates the transfer of data and information between physical and virtual environments. Data storage realizes the accumulation of information necessary to provide digital twin-based services for material handling. The virtual environment provides a digital representation of material handling involving a task scheduling optimizer, a material handling model, and a web-based route and a real-time location application. The task scheduling optimizer applies a dynamic optimization method for obtaining the schedule of material handling tasks, minimizing the delivery, make spend, and energy. Importantly, digital twin-based services in smart production logistics must address the concerns of stakeholders with distinct responsibilities and information needs. A service can be defined as the application of specialized competencies, knowledge, and skills through deeds, processes, and performances for the benefit of another entity or the entity itself. The first group of stakeholders include the material handling operators. Digital twin-based services may benefit operators by providing the location of all forklifts or the distance to points of pickup and delivery, as well as their status. The second group of stakeholders involve logistics managers. Logistics managers require services for operating production plants and a holistic understanding about the movement of materials and information. Factory managers constitute a third group of stakeholders benefiting from digital twin-based services. Factory managers need a predictive service that considers the interrelation of smart production logistics with other subsystems of a manufacturing system.
We applied our proposed solution to systematically manage production logistics and improve efficiency using digital twin-based services in the lab environment. A virtual production and logistics were defined in the real-time location system environment, and the optimized model was executed. If you have any interest in our research group, please visit our website or YouTube channel. You could find interesting topics in production logistics.
Welcome back. Yes, and I would like to welcome a new panel partly. We kept Dennis from Mainly AI, but also introduced Chao Mang from Scania.
Yes.
Welcome. And Eric from KTH.
Hello.
Very nice to see you. So we saw a video on more factory level logistics, internal materials handling focused. And we also 3 potential examples of digital services that you explained there in the video, Eric.
That's right.
Perhaps we could start on your end, and as a researcher, how do you see the state of art of connected logistics, if we say so, within a factory, in gathering data and analyzing data, decision support for operators or design developers, or where are we, so to say?
I would say that we're in a very dynamic point in time, and I would say that it's perhaps very much based on joint collaboration between different actors to really facilitate better production logistics. I think on the one hand, we have, of course, the insight of OEMs or traditional manufacturing companies. On the other hand, we have technology providers who have the capabilities and know-how in order to generate data and or the devices themselves. And universities or research groups that have the interest and know-how on algorithms or digital applications that can connect the dots, perhaps.
Yeah. You've been given some time to think now, Dennis, during the video, and then is there anything more you would like to add from mainly AI perspective on what type of solutions is available for these type of applications that we talk about now?
Well, the AI technologies and machine learning technologies are being applied quite broadly in the supply chain and logistics space at the moment. They offer many opportunities. They obviously, you have, as an example, one can just take finding an optimal location for your warehouse or your distribution center that you do under certain constraints. Right. You can do it under constraints of inventory availability or constraints of proximity to your customers, and not the least, there is also a huge constraint of that everybody's beginning to take into consideration of the environmental impact that comes out of the supply chain activities, so to speak, and you can optimize your supply chain under that constraint of the environmental constraints. However, what we think and what we see is that the pace of implementation of AI technologies is still very, very low and very slow. Okay. And we've discussed that in the previous session. The reasons are many. Yeah. However, the good news is that there is a technology out there. There is a framework that allows to facilitate the adoption of AI technologies.
Yeah, thank you. Yeah, Xiaomang, you're actually one example on what Eric mentioned on the collaborative things, because you're a Scania, but you're also a PhD student at university. Yes. But I understand that you're working more on a little bit on enabling technologies, on the machine learning and computer vision.
Yes.
So how do you see that can be applied in industry from a Scania perspective, with that hat on, so to say?
Yes. So computer vision can have a lot of possible application in production. If now we talk specific in logistics, my research is about quality inspection. So for example, in logistics, we can, after the operator pick different parts, we can have a camera to check if they have picked the correct parts, if the parts are in the right size, and if the parts has a defect on it. So this is for quality inspection. And besides that, we can also use camera to read the barcode or OCR on the package to make sure it is the right package delivered to the right storage. And then it can also, the computer vision can be the eyes of a robot. So you can guide the robot. Instead of operator doing manual picking, you can guide the robot to do automatic picking and guide the AGV to automatic delivery. So besides that, I think computer vision can also use to help the operator. For example, we can apply post estimation on the operator to check if their posts are economy friendly. Or we can check the operator, check the forklift or check the robot to make sure safety. So
Okay.
when the operator closer to a robot or forklift, you should give some alarm to stop the robot.
Right.
So computer vision can have a lot of potential user case in logistics.
Interesting.
Yes.
So what is the main challenges? Is it from a camera perspective, technology, or is it the algorithm, or is it the noisy and disturbing environment, or what is the problem, so to say? Why don't we have it everywhere?
Okay, so this is a very good question. So first of all, I think computer vision technology in this AI area, in deep learning area,
Right.
I would say it can be maybe easier to implement compared to other AI model. Is because if we want to do predict some process result, we need to collect data from all the process. So we need to have data traceability. We need to make sure the data is clean. But for the computer vision, we can just add the camera externally, add the extra camera to collect data. So maybe it's easier to apply. So actually, you can see there is already a lot of computer vision technology inside the workshop, but most of the camera are like traditional image processing algorithm, so they are not using deep learning.
Right.
A problem in using deep learning computer vision in production is normally the deep learning algorithm require a lot of training data. So you will maybe require a lot of time to collect all the training data from production, and then we need operator to manually label all this data. So maybe the training data of can be a challenge.
Right.
Yeah.
Yeah, so the data availability again that we
Yes.
talked about earlier.
Yes, but there's a lot of research in academia about how can we use this limited label data
Okay.
for training. It's
Okay.
like self-supervised learning
Yeah.
or unsupervised learning. So I think there's a lot of possibility. And
Interesting.
my research is like make a bridge of academic research and actually industrial application
Right.
to how to use this research actually in the production user case.
Exactly.
Yes.
Yes. Very nice. Yeah, and you, Eric, also. I mean, we all work actually in this intersection between academia and industry. So, what's your what is on your wish list for the future? What would you like to work with, if you say so?
Well, I think that if we reflect on the previous discussion, and I think the highlight of these sessions is sustainability
Right.
or a strong focus on sustainability. And I think maybe the rest of the panel perhaps would agree on that. Maybe a shift is that perhaps, as in the past, it was maybe more emphasized an economic perspective or being more effective when it comes to production logistics or moving material in a factory. Now we're, I think, increasingly moving towards other aspects that are equally important, such as social aspects, safety, environmental, of course, and this big drive for CO2 emission reduction. Right?
Yeah. Thank you. I think we could spend some time talking about this for longer, but actually we have a third part to look into as well. So we need to move into that. So we'll look on the video on workstation level research. I hope we can see it now.
Hello everyone, my name is Yongguk Jung from the Production Logistics Research Group in KT Södertälje. Today, I want to share our idea on time data management system and its application using machine learning model with you. I would like to start this presentation with my very first impression when I visit the Smart Factory Lab in Scania. We have some guests from Scania today, so some of you may be familiar with this pyramid. There was a sign in the Smart Factory Lab and it describes their digitalization strategies. So as we all know about this, smart technologies and digitalization can be achieved from the standardized processes. If we divide the standard information, it can be divided by time, task, and the information of tools. So many companies have their standard work description for employee training or process improvement and so on. and it includes the tool information. But what about the time data? If we are talking about the machine data, I mean the data from the machine, it is possible to get the data from the machine. However, what about the manual work, manual assembly work? How can we measure and analyze the deviation from the different operators in different situations? So there is a solution. It is method time measurement, which is MTM. It defines all the manual operators movement based on the unit movement. As you can see here, from body motion and hands movement and even eye movement. And it defines standard time data for each unit movement, so we can calculate the expected time for each movement based on this standard. However, even though we already have a standard information, we need to improve our standard time data, or there are some cases that we cannot define and calculate based on the MTM data. So in this case, we need to measure the time data from the operators by ourselves. So there are many researches has conducted about the time data gathering based on the sensors or some other technologies. It could be measured with these gears or suits, but I'm not sure our operators are happy about this, and it costs a lot to use these sensors. So I would like to suggest a new method to measure and analyze the time data using machine learning algorithm. As we know, machine learning algorithm is a good option to categorize the data based on the input data. However, developing an algorithm is a different story. We are not the programmer and myself as well. So here is another solution to use machine learning model without advanced knowledge of the programming. This is a teachable machine service developed by Google. And this service has an easy user interface to train the model and execute the model. You can just upload your webcam images or movie clips. As you can see in this example, I have uploaded some movie clips and trained the model with 3 different movements, which is waiting, moving, and assembly. And this model can distinguish my different movement based on the trained model. And it is easy to export this model and integrate together with the current time data management system. And I believe there are many possible options and technologies to get the time data and analyze the data as well. So what do you think? Do you think this is the future for the time data management? I would like to listen to your opinion. Thank you for your attention.
So, welcome back. And I would like to welcome the new panel once again. We have a panel consisting of John Cook from KTH. We have Thomas from Scania.
Hello.
We have Jose from Scania.
Hello.
And Juan from Scania.
Hello.
So we have a super team here of technical experts working closely with the smart factory as well at Scania. Very nice to see you here. So now we saw a video focusing on specifically on time data management, but of course we're free to discuss more freely on workstation level. I think that we can agree on that we're working on that type of system level at least. I just pick Juan as an expert from Scania working on human-robot collaboration aspects. How does this time data management relate anything to you or?
Yeah. I would say actually like one of the struggles when we are designing this type of collaborative stations where we have a collaborative robot working alongside a human and not just coexisting in station, but they actually collaborating with each other, working with the same parts, sharing the same space. It's a struggle to really get the timing right, let's say, to have the station optimized in a way that the operator doesn't have to wait for the robot to finish his task, or the robot doesn't have to wait for the operator, but that they actually synchronize in a good way in order to optimize the time. Having this kind of time settings or standard times for the different actions makes it much more easier, much more simple to develop and implement this type of station and this type of robots and collaborative stations, because now we can use, we know which operations we can take away as a block from the operator and have the robot performing them, and we know that they are going to be synchronized or aligned in a good way with each other. And thanks to this, actually, we could also take advantage of one of the main pros of collaborative robots, which is their flexibility, that you could somewhat easily take them from one station, move them to another place, reprogram them, and have them working in that different station. When we have these standardized blocks and time settings, we can, as I said, just go to the new station, say, okay, we can have the robot perform these tasks, take those away, that block, and we have the robot filling in that time. So we can very easily integrate it.
Yeah. There are so many questions that rise ahead when you hear about this, because how do you set the times then, and how? So that's
exactly. So that's another question. What are good methods of having this type of time settings? So we at Scania, for example, have our own Scania time setting system, where we are trying to standardize all the times that it takes for an operator to do certain type of very common actions, like pick and screw, putting it in place, etc., tightening it. So, but we see a lot of advantages from using this type of standardized time setting systems.
Thank you. Jose, you're also working in the Smart Factory lab, and what's your focus, and how does it relate to this area?
Actually, I can follow up on what Juan was mentioning related to time setting and how time is measured for the specific tasks. There are some tasks, if we look at a process level, and this is like, for example, if we look at assembly and try to standardize the way that time is measured in assembly, there are some tasks that are quite difficult to standardize because they are very variable or not very, they're not done in the same way every time. For example, when you're assembling flexible material, like hoses or electronic cables, this can be quite difficult to standardize and then measure. And on the other side, we also have on the method level, that it could be a bit difficult to actually measure time, because nowadays, for example, in the Scania time measurement way we use, and many other ways that exist, the typical way that you do it is you take a recording of the assembly task in this case, and then analyze it afterwards. And Jake is proposing also a way to do this automatically with machine learning. But there is also some tasks that don't have a differentiating moment. For example, it is very difficult to differentiate between a quality inspection, where a person is only looking if something is well placed, with a waiting moment, where a person is just standing there also looking at the machine. And then how do you really incorporate this into your time measurement, and how do you even automate it at a later stage?
That's another. They're a topic for collaboration here. I can hear.
I also got some inspiration from here today.
So Thomas, your focus is actually more specifically on sustainability and energy efficiency, if I understand it right. So what's your and you're also actually a PhD student, but employed at Scania, just as we had Chao Meng before, but then linked to Uppsala University. So how? A lot of questions here, but could you give some reflections on your situation?
So I'm also bridging between the industry and the academia in that sense, as an industrial PhD student. More looking at how we can create more resource efficient processes, also on a workstation level. And we face similar challenges there. It's also a lot about first identifying the main consumers of the different workstations. What leverages do we have? Who are what are the process times that where we consume the highest amount of resources? And then effectively trying to challenge that and adopt the process in a way that creates a more resource saving. That is also something that we apply on a workstation, and should be something that should be applied throughout the whole process, even very early on in a workstation design. Think about can we choose maybe energy efficient machinery from the beginning. Now looking at a production line that is already in place since several decades, working with legacy equipment, we face challenges of collecting the data, as mentioned, identifying the consumers and then taking effective action on that. But a lot of leverage, that there's still a lot of potential.
So, yeah, there's a lot of challenges here, obviously. Are they equal in, or is it, you mentioned, collecting data availability again? Is that an issue, or conflicting objectives of stakeholders or parameters or scorecards? Is that a problem? Or what is...
That's a good question, of course, because the more granular we have the information, the more precise we can adjust the process, of course. But it should not be, maybe it's a little bit of a rebound effect you would have, then you would improve the sustainability of the process, but by attaching more and more hardware on thousands of machinery around production, that would sort of defeat the purpose in a way.
Right.
So also thinking of, Jake has introduced the concept of a teachable machine, of machine learning.
Right.
I think there's also a lot to gain from using data analytics and trying to find the right process setting in order to run more resource saving without having to attach too much new hardware.
Yeah, thank you. Yeah, Jake, John Cook, I should say. Yes, you're an assistant professor here at KTH.
Yeah.
What do you said you got inspiration, and what do you foresee as the challenges, or what would you like to work ahead with?
Yeah, actually, they already mentioned all the answers that I want to answer, so it's a little bit difficult to answer at the end. But as Juan said, so one of the applications that we can use this time data is a human-robot collaboration, because we also want to know the exact time for the human operators, and as Jose mentioned about it, so we also want to try the how to focus on, because as he said, like some flexible materials or some specific tasks, they are a little bit difficult to measure. So at this moment, we are focusing on what kind of task is difficult to measure, and we want to find, in this situation, we have these technologies, and we want to try to match some example cases and some technologies that we can help the industrial partners. So that is the one thing that we are doing right now. And also, I want to emphasize, we already mentioned sustainability several times before, and you already mentioned about the environmental perspective, but also we also want to emphasize human is not like a robot. We cannot work 24 hours, 7 days with like a difficult, like an ergonomic perspective. It might be difficult some position for the human operators. Right. So using this standard time data, or using this some supportive workstation level, we want to also emphasize how can we keep this technology, or how can we help the operators, not just for the cost-effective or the environmental friendly, but also the social perspective. So we want to also have these technologies or this task sustainable way. So that is what we are focusing on as a research level, and work together with the industrial partners.
Yeah. So thank you. I don't know if anyone has some more comments on anything.
I could add something to what Jay was mentioning when you are trying to, because this concept of having some video feed and then you try to analyze it with AI. There are some points that can be quite challenging, and for example, it is that you don't want to introduce tasks into the human behavior that are not part of the process already by itself. So it could be quite easy to measure, for example, assembly time. If the operator would clap at a certain point and then clap when he finishes this, but this is adding waste into the process. So you need to find a good way to introduce this technology without disturbing the way that the operation is already done today.
And maybe one more thing I just forgot to say, the data privacy is also very important in this field, because we are capturing the data to collect the data. Like for example, we are filming the human operators, and maybe this film is related to their performance. Maybe they don't want to share their performance level to their system. So this kind of like a GDPR issue or some privacy level is also need to be considered in this field.
Yeah. Thank you. I thought we had 55 minutes. We could spend a lot of time, but time flies, and it's been really interesting to discuss this with you. So the objective of this whole session was actually to give some examples on how industry and academia can work together. We tried to look on 3 different system levels, looking at production logistic applications, but seeing how technology can actually contribute to sustainability analysis and better decision making. So by that, I thank you all, and feel free to contact us if you have any interest in collaboration on production logistics.